Welcome. This lesson is about chords and the arcs that they intercept. So if I have two congruent chords, the arcs that they intercept are also congruent. I can also say the converse of that. I can say that if I have two congruent arcs, the chords are congruent. Okay. If I have two chords that are equidistant from the center of the circle, the arcs that they intercept will be congruent, and those chords will actually be congruent. I also get to say the converse of this. So if I have that those arcs are congruent, I know that they'll be, the chords that intercept them will be equidistant from the center of the circle. If I know that those chords are congruent, that I know that they'll be equidistant from the center of the circle. So we don't have to write those all out. We can just write and its converse. Right, and if I have a chord that's perpendicular to the diameter, I know that it will cut that chord in half. It'll also bisect the arcs. I also know that its converse is true. So if I have a chord that is bisected by a diameter, it must be perpendicular. Great, so let's look at some examples. In this first one, I know that if I take 18 and 18, I get 36. That makes both of these chords congruent, so I know that they'll be equidistant from the center of the circle, so x will be 16. In the second one, I know that I could draw an entire diameter through. This would make it perpendicular, so these two pieces would be the same. I can use the Pythagorean theorem to solve for this piece right here, so let's do that. And take the square root of both sides, and I get 5.5. B is equal to 5.5. That's great that this is 5.5, but I want the entire length. I know that because it's perpendicular to that diameter, that this will also be 5.5. So I add them together and get 11. So I know x is equal to 11. In this next one, I know that these are equidistant from the center of the circle. That means this piece is 7 and this piece is 7. So together they will be 14. That means that x is congruent to it, and it's also 14. Similarly, these are equidistant from the center of that circle. I know that this is 12.5 and this will also be 12.5. That makes the entire thing 25, so A is 25. Okay. In this next example, I know that this length here is 2, and I can extend it out to get a diameter, which means that this is bisected. And I also know that this radius here, and I can move a radius wherever I would like. So I'm moving it right here, and now I can use the Pythagorean theorem. Two squared plus b squared is equal to 3 squared. So I get 4 plus b squared is equal to 9. B squared is equal to 5. I take the square root of both sides, and I get that b is equal to 2.2. Well, I just found 2.2, but I need this piece over here, which would also be 2.2. So the whole thing would be 4.4. In this next one, I know that because this is perpendicular here, I can extend it out and get a diameter. This is split in half. So I have 8 and 8. I have 2 congruent parts. I can also take this diameter and cut it in half and have 10 and 10. I want x, which is this length right here. So I'm going to use the Pythagorean theorem once again. And I'll do 8 squared plus x squared equals 10 squared. 64 plus x squared is equal to 100. X squared is equal to 36, so x is equal to 6. Okay, in this example, I have 2 radii, so I know this side is also 6. So I'll just use that Pythagorean theorem. And I get 8.5 for that value of x. Okay. For this example, we're going to find our radius. So I'm just going to draw one in over here. I don't know what it is, but I know it's the same length as this one that I draw in over here. And they tell me that this piece here is 5 and this one is 2. So we'll use the Pythagorean theorem again. We get 2 squared plus 5 squared is equal to c squared. 4 plus 25 equals c squared. 29 equals c squared. So c is equal to 5.4. So that's the length of our radius. Our radius is 5.4. In this next example, I have x on a radius, and I'm just going to move it up over here. And I know that because this is perpendicular, each of these are 4. So now I'm going to use the Pythagorean theorem because I have that right triangle. 4 squared plus 3.6 squared is equal to c squared. So I get 16 plus 12.96 is equal to c squared. That gives me 28.96 is equal to c squared. We take the square root on both sides, and I get 3.6. So x is equal to 3.6. In this next one, I see that these two chords are congruent. That makes the corresponding arcs congruent. So I have 3/4 of my circle filled in. I'm going to take the sum of all of the angle measures and I'll subtract that from 360. And I can find this last arc. This is a central angle, so its value will be equal to that arc. Okay, and we're on our last set of examples. So I know that these two chords are congruent. And I know that this is a central angle, so this arc is 25. Because the chords are congruent, this arc will also be 25. So x is equal to 25. If I look at this problem, I know that I have 5 congruent chords. That's going to make 5 congruent arcs. I know that all of the arcs add to 360, so I'm going to go ahead and divide that by 5. That gives me 72 degrees for each arc. Well, I want to know the central angle formed by these two arcs. So I'm going to add that together, and I get 144. So this central angle has to be 144. So x is equal to 144. All right, that's it for your notes on this topic. If you have any questions on this or any material from this unit, please make sure you ask me in class. I know that there's a lot of theorems that work with chords, so you might want to put some of them on index cards and study them. We'll recap this lesson tomorrow and do an activity. Thanks!